Hi kids, it's Mrs. Buckley. Today we're going to talk about three-dimensional figures. And three-dimensional figures are simply figures that take up space. My fist is a three-dimensional figure. My foot is a three-dimensional figure. So I want to take a look at some different types of three-dimensional figures, which you'll recognize. So here, happy Thanksgiving. This is a cylinder. Obviously, it's like a tube. So it has a bottom and a top that are congruent and sides that go straight up and down between the two bases. So there's a cylinder. Here's another one. My nice can of tuna. So it has a circular base, another circular base that just so happens to be parallel to it, and rounded, but sides that go straight up and down between the two bases. So there's some cylinders. We also have something called prisms. And prisms, just like cylinders, have matching tops and bottoms, but they have rectangular sides. So for instance, a box of crackers has the top, the bottom, and rectangles along the sides. So there's one example of a prism. Here's another example. So you can see that it has rectangles along the sides, and the top and the bottom are congruent. So rectangular prisms. We call them rectangular prisms because the bases are rectangular shaped. So here are some others that I made this morning that aren't too beautiful, but they'll do the trick. So here, there's a trapezoid, right? It's actually a right trapezoid because of that right angle right there. So what I did was I cut out two matching trapezoids and I connected them with rectangles along the sides. So this again is a prism, and it's called a trapezoidal prism. Let me get a label for that. I have it right here. So a trapezoidal prism simply means a prism with a matching top and bottom that is a trapezoid shape. Those two bases are parallel to each other, and it has rectangles along the sides. I also have a triangular prism. So it has a matching top and bottom that are triangles and rectangles along the sides. So that is a triangular prism. Here, this one was really not easy to make. So here's a pentagonal prism. So it has a five-sided shape, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, which makes it a pentagon on the top and the bottom. And we call these lateral faces. The lateral faces are all rectangles. Whoops, I could have done a better job taping there. But you get the point here. So we have prisms. And again, in this case, it's a pentagonal prism. And prisms, just as a reminder, are always named by the shape of their bases. So even if I turned it on its side like this, it's still a pentagonal prism because we identify the bases by the two faces that are parallel to each other. So here's something kind of cool. Whether I have a cylinder, or let's get my trapezoidal prism back out, as long as I have a figure that has two bases that are congruent, whether they're circles or any kind of polygon, and those bases are parallel to each other, the way I can find the volume of the figure is by taking the area of one of the bases and multiplying it by the height. So let me say that again. If I have a cylinder or a prism, the way I can find its volume is by finding the area of the base, in this case a trapezoid. So you'd use your area formula for trapezoid and then multiply it by the height. And same thing with the cylinder. We would find the area of that circle and then multiply it by the height of the cylinder. And that works for any type of these shapes. Here's my triangular prism. I would find the area of the triangle, multiply by the height. My pentagonal prism, take the area of that pentagon and multiply it by the height. And with the rectangular prisms as well. So we're going to practice with rectangular prisms and cylinders. Now, you may have learned that finding the area, the volume of a rectangular prism is length times width times height. So length times width times height. And that's very true. The reason we can use that nice easy formula is because when we do the length times width, what we're really doing is finding the area of the base and then multiplying it by the height. So that length times width, part of the volume formula for a rectangular prism, just finds the base of the area of the base and multiplies it by the height. So let's try a few.